Hello. 7.5, that's where we are right now, which is the mixed bag of all sorts of integral ideas all in one homework section. So you have to take an integral and decide which idea or ideas apply. So what I did was I took problems 5, 7, 9, and 11 from the book, and we didn't finish any of them, but we started them by deciding what they are. This is what you have to do when you're working on 7.5. It's also a great practice for you're studying for a final exam. This is really good practice because here's everything all mixed together. So let's see what we got. Problem 5. That's the original integral in problem 5. I recognize it's an inverse tangent problem because I have something squared plus, I could make that a 1. Go from here to here. Let me erase this other guy. This guy, we don't even need to see this. That's from our discussion in class. I want to make that a 1. So I factor out a 2. That's like a 1/2 here. But when I multiply back out, I got to get this regular t to the 4th back. So there's a 1/2 in front of this because this 1/2 cancels with that 1/2. I'd get a 2 here. So these two lines are the same. And then 1/2 t to the 4th I can rewrite as 1 over square root of 2 t squared quantity squared. That's not the problem done, but I see that I'm going to have something squared plus 1, and I can adjust that to be the derivative of this. I'm going to get 2 over square root of 2t, and I've already got the t. So it's definitely inverse tangent. Number 7. We notice that you have e to the arctangent y, and it's times 1 over 1 plus y squared. Well, 1 over 1 plus y squared is the derivative of arctangent. So this is a regular old chain rule problem. So that's why I wrote chain here. It's a chain rule, and that's the actual integral. We got space. We didn't finish it. But arctangent of y and arctangent of 1 and arctangent of -1, your calculator knows if you don't know. All right. This little triangle goes with the last problem, not this one. All right, looking at number 9. We spotted that you can factor the downstairs. Ah, well then this is partial fractions. That's 7.4. You got to go off to the side, do the partial fractions, rewrite this integral, and you're going to get something over x plus 4 plus something over x minus 1. Both of those are natural logs. Then you're going to evaluate the limits of integration. Number 11, what are we going to do? I'm looking at this problem, and this square root of x squared minus 1 tells us everything. I can't get rid of it. This x squared down here is x cubed is a real problem, and I don't have a single x up here, and I can't have one. Because I could do derivative of the inside if I had a single x up in the numerator, but I don't have a single x. I've got an x cubed down below. So x equals secant theta is literally our only hope. It's our only hope. So if x equals secant theta, dx is secant theta tangent theta d theta, I substitute it in. See these arrows here? I substitute it in, and lo and behold, all sorts of stuff cancels, and I end up just doing the integral of 1 over secant squared. And 1 over secant squared is cosine squared. Well, cosine squared, remember, we can handle any trig word to any power, like 1, 2, 3. We can handle them all. Well, I can handle that, and that's this substitution. So I stopped there, but we're done. The main thing is to spot number 11. You got no other option. Number 9, no other option. But number 5 and number 7, the pieces are related, but how? You have to tease out that relationship, and then you get it. So that's what you're supposed to be doing in 7.4. So try those things. See how much you can get done.